Hello everyone, welcome to part 4 of our video series on accessing and configuring an ESP32 microcontroller. First off, we're going to recap what we did in the previous videos. So in part 1, we downloaded the software and utilities that were required to access and configure the microcontroller. In part 2, we erased the microcontroller and we installed Micropython on the device. And then in the end tested to ensure the installation was done successfully. And in part 3, we configured our microcontroller to automatically connect to our Wi-Fi network. So in this part, we're going to set up our ESP32 to generate some test data, and then we're going to show how to transfer that data from the ESP32 to our server. We have a Linux server on this side that we're going to be transferring the data to. We're going to set up a listener to listen for connections from the ESP32, and once connections established, we'll transfer the data and it'll be stored on the server in JSON format, a JSON file. So let's begin. First thing we want to do is set up our listener. So we have a terminal open to our Linux server. So we'll VI, we'll call the file test.py. This will be our file that we'll use to create our listener. And we'll hit I to insert our code into the file. So first step is to import the libraries that we'll need. So we'll import socket and we'll import JSON. Then we'll move down and we'll begin creating our socket. Zero dot zero dot zero dot zero, and I use port 8081. I have that opened up on the firewall on my server. So if you want to use a different port, you'll have to also open that up in your Linux server. And next. Socket. And bind. And then listen. And listen is, we'll have 1 in the parentheses. Next step, in this next step, we'll print a message when we execute this script. It will continuously run, and we'll print a message saying that it's running. So basically this will say listening on address, and it will be 0.0.0.0 for the address. Next, we'll set up the listener to receive the data from the ESP32. So we'll receive a file name that will be created on this server, and we'll receive the data after that that will be saved in the file that was created. So let's go ahead and do that. And we will have to tab these. Indenting is very important in Python. Everything will fail or the file will fail to run if it's not indented properly. So accept incoming. Tab, print. A message. So when the ESP32 connects, it'll print a message to the screen on the server that a connection has been established, and the IP address of the ESP32 will display on the screen. Tab, file name. This will allow us to receive the data from the ESP32, the file name information. And it will be in UTF-8 format. And once that data begins transmitting, we'll receive a message that says receiving the file name. And then we will begin the process of creating that file on the server. So open, file name, and then write to the file. So the next step will be sending a message back to the ESP32 saying that the file name was received. And that will display on the ESP32's console. Make sure you have all of the open and closed parentheses matching. And now we're going to do the same thing for the data that will be stored in the file. Again, indent. And again, we'll have the entry that allows us to receive the data being transferred. And again, decode UTF-8. And that looks good. Next line will be print. Print the message that we were receiving the data. And then the command that, the line that writes the data to the file. And when we're finished, we'll send a message back to the ESP32 saying that we received the file data. File data received. Encode, again, UTF-8. We will do a file close to close out the new JSON file that's been created. And again, make sure the indentation is done properly. And we'll print a final message. Disconnected once the data has been transferred successfully. All right, that looks like that's it. So we will hit escape, shift, colon, WQ, exclamation point to write and quit to save this file. And let's run the file to see, run the script to see if we've done everything correctly. So we'll type Python and then test py. And we have a typo. So that happens, we'll go down and figure out what we did. And it is right here. We're missing the parentheses, so we'll do hit A, add our parentheses, hit escape, hit right quit, exclamation, enter, and we'll arrow up and run the script again. And here we go, listening on address 0.0.0.0 on port 8081. We'll do a netstat. And we'll grep for port 8081. Come on. Oh, well, we can't really. So we'll do this. We'll do a Control C. We'll run this script again, and we'll use the ampersand so it runs in the background, and then we'll run the script again. And then we'll arrow up back to our netstat command, which probably didn't save in the history, so we'll run that command again. And there you go, there's our listener running on the system. It'll run continuously until you kill the process. And you find that by running the ps command, and just run grep for test, and you'll see Python test py, and the process number or ID is 387167. So you'll do a kill -9, and then you'll do 387167, enter to kill that process. Now that we've created our listener, our next step is to configure our ESP32 microcontroller. So in this step, we are going to open Thonny, and if not already done, connect the microcontroller to our workstation. And once it's connected, we'll hit run, stop, restart backend to establish our connection to the microcontroller. And just real quick, let's open up our folder here, which gives us the option to access the computer or Micropython. In this case, we want to access Micropython device. So we click on that, and Micropython by default, during the default installation, creates a boot.py file. We need to create, in this step, we need to create another file called main.py, where our program data will go. Once the machine boots up or the device boots up, it reads the boot file, and then the next step is to read the main file where our application or our program is stored. So let's cancel this. We don't need this area right now. And let's go ahead and hit new up here. And let's begin doing writing our code for the microcontroller. First thing we need to do is import machine, or import our library. So import machine. Import socket, and import JSON. Next step is to generate our dummy data that we'll be using. So we're going to print out a range of numbers from 0 to 9, and we'll use that as our dummy data. Jeez. And these numbers that are generated will be stored in the num empty set that's created above. So we'll print num. In our next line, just to demonstrate how that looks. And then we'll begin to do our calculation on the numbers that are listed. In this case, out will be our averaging of the numbers that are printed to the screen, the 0 through 9. So we will sum numbers, or num, which will add up all of the numbers from 0 to 9. And we'll divide that by the total of the individual numbers, which would be 10 numbers. And we'll convert that into a percent. And this will give us, convert our numbers into a percentage. And then we'll dump that into a JSON dumps. Which we'll prepare it to be put into a JSON format. And we'll print to the screen to see what it looks like. And we'll open our file and write to it. So I have this generating the file on the server, and I also have it generating a local copy of the same file. So once we run this, we'll see a file stored on the microcontroller, and we'll also transfer the same file and data over to the server. And we're going to call this sensor2. And we're going to write to that file. Now we're going to put that into JSON format. This is kind of touchy. There are different JSON formats depending on what type of data you're transferring, so you have to make sure you use the right one, or when you try to use it, it won't display in whatever you're trying to use it for. This is sensor2. Let's see. And then plus string JSON out. Plus there. Hoping that's correct. And then we will do close the file. Let me see if I have this right. And I think that is correct. It's good as if you have an error in your code, like you saw it grays out the block of code in that area where your error is, so that's useful. And now that we've formatted our data and saved it to a local file, we're going to begin the connection, the socket on this end, to communicate over to the server and send the data that way. So and this will be the IP address of our destination server and the port that we created over there for the listener. Let's see. Net. Socket stream, or sock stream. And close the parenthesis. Now this will be the command to establish a connection. It's calling the IP address that was listed in the address line a couple lines up. And again, we're going to open the file. Which is sensor2 JSON. And we are going to read the data in the file. And then we're going to, well, read the data in the file. We'll open the file and then read the data in the file. And we're going to send the data. Sensor2.json, encode, UTF-8, again, make sure you have the proper number parentheses. and decode. And we will print a message. File name received. And we will do the same process for the data. This is identical to the information that was sent, or for the code for sending the file name. So, and decode. UTF-8. And we are going to print file received. We're going to close the file. And we're going to close the connection. And that should be it. So what we need to do now is save this. And it should give us the option to name the file. We'll save it to the Micropython device. And we are going to name it main.py. Hit OK to save it. Now that we've finished creating our code for the microcontroller, our next step is to test our code to make sure we can successfully transfer data. One thing that I need to show you is the IP address here. When we did this, I had a typo, so make sure when you do this, your formatting looks like this, and not like it was when we initially typed it out. So let's see. First thing we need to do is open up a terminal on our Linux server. Earlier, we created the test.py file, which is our listener, which contains the code for our listener that will be listening for incoming connections on the server. So let's go ahead and run that. So Python test.py and then the ampersand so it can run in the background. And you see we're listening on 0.0.0.0 port 8081, which is how we set it up. Now let's go ahead and run our code. So we'll go to run here. We'll do a stop restart backend. And we'll see what happens. We see on our microcontroller side, we'll see on the server side that it's receiving the file name from our microcontroller. And it also prints that we're receiving the file data from the microcontroller. So we've made a successful connection, and we're successfully transferring the data. And we see on our microcontroller side that the server has received the data or the file name, and it has received the data. So once that's complete, the connection closes, and we see over here disconnected. So we've successfully run our script, or transfer data from our microcontroller to the server. So let's see what we have over here. We have sensor2.json, which is the file we generated from the microcontroller, and let's go ahead and more this and see what we have inside. We have the data from our microcontroller in JSON format. Now this JSON file can be used, I use Plotly to create charts and gauges and things like that on web pages, and I use a JSON file, this JSON file, to read in the data into that chart. So now that we've done this and it's successful, we're going to move on. I'm going to do one more video, and this will be the last one. I'm going to show how this data can be used in a web page using Plotly to create a, in this case it'll be a gauge, and we'll demonstrate how that's done. And that will be part 5, I guess, of our series here. So thank you for watching. I think we're done here. Again, thank you for watching, and please subscribe or like or whatever you choose to do. I hope to do a lot more stuff here, so please keep checking back, and we'll try to do some fun things or some interesting things or whatever we can come up with. And thank you. Talk to you next time.